got x square 2x. So always you have to take care of this part. This is most often we cannot find certain symbols, we have to use with the keyboard. So x square, that 6, this top of 6, you can see the caret symbol, that is a power exponentiation symbol. So star is the multiplication. All those things are known to us, so you have to utilize that part to that. So once you know this one, what is the advantage of doing this way is it is almost equivalent to natural language way of expressing it. So this is also important to when you are working with various math software such as Wolfram Alpha. There is one thing called as WOLFRAM ALPHA. Wolfram Alpha is also one similar tool available. You can attach with your browser and you can solve all kinds of mathematics can be solved. So that is one more. But if you want step-by-step problems solution, then you have to buy. So otherwise, it is only give the solution. That is also a nice thing. It is context aware also, far better than our Google search engine. So obviously, you can see, verify it. So now, once you've done it, f of 3, as I said, you can do this way. Or what is the other method we can do is here I said f of x dot substitute x equal to 3. If I put this is what you're going to get this one. So now the same thing I'm doing it. So f of 3, f of x equal to substitute x equal to 3. We got 15 by 2. So now, then other way is how to define how those who are teaching mathematics and computer science, you can see always mathematics as well as the function in any programming language is one and the same. When you define a function, obviously the image is going to come. When the programming language, the function, every function supposed to return a value. So the same way here also we can think it of. So once you know that meaning, so we are defining function. The syntax for function is define f of x, then the colon return what it has to return, the function whatever you defined it. So if you say the same function has come out. So many ways one can define function because of the syntax availability. So this is useful certain places, especially piecewise function. I don't want to use the syntax of piecewise, then I can use this kind of things. Return this if x is less than 1, or if otherwise else return something. So that is a place you can think it of. This kind of things can be utilized it. So now the same thing I'm talking about this. Define piecewise function. F of x is given by tan pi x by 4 if x is less than or equal to 1, otherwise f of x. F of x is x. So how to define, as I said, now here you are able to see that absolute value of x that is known to us when the syntax says abs of x. So less than or equal to 1, return pi. So pi x by 4, whenever you say pi, natural language way of writing it, star x by 4, otherwise else return x. So if you compute it, it is going to give this one. This is not given the value because I've not installed certain functions. So packages, therefore you are going to get. So standard things will get tan pi by 4. Now our focus is now comes to the graphs and limits. So obviously we have to talk about how to draw the graph of the function. As I said, this graph is very important in data science. Also visualization of data is very important. So therefore, when you talk about visualization using the graphical methods, you should play with multiple things. So multiple things in the sense, what is that? Can I draw this kind of graph? Can I plot this 5 graphs in the same coordinate axis? So can I have graphs adjacent to each other, 2 rows and all those things? One has to play with that. So here our interest is only to, can I draw in a particular given function as a graph in a single coordinate axis, or more than one graph? Why do you want more than one graph? Suppose we are normally we ask find the equation of the tangent to the curve at a given point. So I also want to picturize whether really it touches one point or not. So how you can differentiate in the classroom, that is the only way we can differentiate. I can do chalk and board, that is the easiest way, but modern world and students also interested to play with systems and other things. Obviously, this is going to give us handy. So therefore, the syntax is very simple. This is the simplest form. Now you look at this, the first one is plot f of x, what are the function you given, then the range of x, where do you want this part? So x is -4, 5 I written. So I'm not talking about y. So what, suppose I want to talk about y part also, I can define the syntax is changes like this. After 5 put a comma, y min, what is the minimum value of y, comma, y maximum. So you can put So now the default line color, the graph color is blue. If I want to change the color, then you can define color equal to red, brown, what colors are available. So for that, you should know the libraries, what is available from the library, what is this. Suppose here, it is easy to define standard colors. Most in the programming languages, these colors are given in the hexadecimal way. So you should know the color codes, then it is easy, or standard colors we can use. So this is, then I don't want this kind of the straight line, I want only dash dash. Then you can say line style, so many syntax. That's what I said. That is depending on your interest. Suppose I want to draw two curves in the same one. One is a solid line, other one is the dashed line, other one could be asterisk or small triangles. You can play with that. So that is important. So now what is this? This, when you talk about this, we know how to represent a given function as a graph. That is much easy. Now sine 3x along the interval. So now we are restricting -4, 4. So this obviously we are talking about the x-axis only. So therefore we know, because if the function is in terms of x. So if it is implicit function, then how to go about it. So there is something called as implicit underscore plot. So that is what we have to exploit. So suppose I want a three-dimensional 3D underscore plot. So that is Sage Math manual gives what kind of graphic is possible. So our this workshop is concerned, we are not going for implicit. Definitely we'll go for it, but not for the 3D plots and other things. That is possible. So anything and everything is possible. Only thing is we have to explore. So plot 3x, x, 4. So this graph looks nice. So you can suppose instead of 3x, you can put the x, and so two graphs, you can put it one coordinate axis. Then you can say how the 3 is, the amplitude is changing this things. All those things can be discussed. So therefore it is much easier way than doing in the board. So now two graphs I want to draw. So I just put both f of x and g of x in the same graph, the same coordinate axis, as well as the same value I've taken it, so that both will have this way. So in the same coordinate axis with different colors. So this problem is standard problem. Therefore, if I want to define this as one color, then I should not use both graphs in the same plot. So I have to define in a variable plot g1 equal to plot x square plus 2x, x comma minus 3 comma 3 comma color equal to something. Then g2 equal to plot sine 2x, x is minus 3 comma 3 color equal to something else. So when I define that, the same thing will appear. But when you say g1 and g2, you just done the programming part, not explicitly asked to plot it. So what you have to do is show the g1 plus g2. So then it will show that part. So the same way, now when I do this way, now the interesting problem is not necessarily always. Why I said is you have to go through it, is you have to practice many problems. Sometimes the graph, because of our syntax, because of the range limitation, we may not get exact plot. So for example, here you look at this 2x square plus x by x plus 2 divided by x plus 1 is one function. Other function is cos 2x by 2. So look at this. Whenever the argument we are writing in the trigonometry function, that's supposed to be in one brace. So within a brace, then there is a multiplication, then asterisk mark is there. If anything is missing, you will get error. So now here looks like I could not visualize anything. There are two graphs, yes, but what is it what we are expecting? So what we are to do? So can we increase the range? So we'll try that way. Now if you look at this way, 2x square, what is the difference? X is minus y comma 5 is the same range, minus 5 comma 5. I've taken that. This is the place when it is not, we are unable to see any differentiation. Then you can talk about y minimum, y maximum. Now the graph looks in totally different way. Now this blue line, what is this blue line? The vertical line is, this is, you know what it is, asymptotes. When you go for that time you can find out what is the meaning of that. So as I said, plot various options we have. So f of x, a comma b, title, if you want to put the title, you can put it. So the fig size, as I said, the size of the line, the graph line, how thickness, it's a number supposed to be given. So color, you want to do color, as I said, line style, then the thickness can be given, legend can be given. Also, sometimes we forced to write what is the units in the x-axis and y-axis, that also can be given. So anything you want, you have to play around this, you'll get this one. So plot x power 4, x is minus 6, figure size 4. When I given this way, this line says, so what is the standard size? Default is normally 2. So you can increase to whatever the line. So now if I change the line style, so you'll get figure size color red. So you can see the differences. You can see this, whatever you want, you can do that. So now I want within a box. So that is common sense, frame equal to true. If you put, you will get the graph this. As I said, when it is a 2 variable, so then we have to talk about like this. When you are saying variable x comma y, and implicit plot x square by 2 plus y square by 4 equal to 2. I'm writing here the values of x is -3 to 3. Within that range, y can take the values -5 to 5. So we got the output h. The moment you put h, you are getting an ellipse. So this is the basics required for learning calculus. Beyond this, there are 2 more syntaxes required. When it is needed, we'll talk about that. What is that? Is how to construct table. So that is just given a for loop. So when you go for calculus, we can talk about that part. So meanwhile, you want to try something on a Sage Math cell. I'll break for 2 minutes. Anybody opened it? Any doubt? Anything we can talk about that part. So now, suppose I want to do simple way. What is the first part of this? Is I'll remove this part. This is the only thing I said. Drawback of this. So otherwise, we can do here. If I want to find limit x square plus 2x, okay, 2 star x plus 2. I want to put this one. So limit f of x is completed. So x equal to 2. If I do this way, I'll get the value. So value is 10. So you know how to come. So also looks simple. Limit x square plus 2 is star x. The problem is when you do this with, why should I do directly? I can substitute it. I can get the value. Why should I use a code? Yes, obviously it is not required. But you say when you want to take left limit and right limit, suppose I want 2 plus. So what is 2 plus? The sense it is. So how to define 2 plus? I'll just change it as this one line, direction equal to plus. So now (10). Suppose I change this value as minus. What happens? Minus. We are happy because left limit equal to right limit. Therefore, limit exists. One can say, and we can conclude it. But you want to see actual definition. How did we do that limits when we introduced? Probably we'll be introducing in +1, +2 level, not in the college level, but however it is required. When you talk about that, there is a sequence of values supposed to converge, both supposed to converge to same value. So how to do that part? That is a place we require table. So probably next class, that is tomorrow, I'll expect you to come with Sage Maths, open it, and we can do something. So now I'll go the part of calculus part. I'll go here. So this is what I explained to you. I'll put it a little bigger way so that so limit f of x equal to a. It gives, suppose if you want the left limit, you can put the minus sign, direction you are defining it minus. So this is a problem. Is supposed to Markdown supposed to you work with the LaTeX. Yesterday it failed it. So some reasons probably I have to check with my tech distribution. Tech distribution is working precisely or not. So this the notations. What we are doing is limit extends to a, 2x square plus x plus 4 divided by x plus 1. As extends to 1, what happens? So that's what we are defining it. So now we are going to put as a general way of first introduction, left limit and right limit. So we need a sequence of values. So for that, I'm going to construct a table. So function definition is known to you. I can write directly f of x. Instead of doing that way, when I write this way, it's a function. I can substitute various values of x. So therefore, this is what we are doing here. Now we are going to say, look at this line. I into step plus initial. So this is I starts from some value. How you are defining step is 1 by 100. So you are going to define 1 by 100 in the sense 0.001. So 0.01 if you put here plus initial value, so float 9 by 10.9. So this value we have to compute f. Then when your step sizes increases, obviously it get increases. That is a for loop takes care of that part. I is varying from here. First time I is 1, second time 2. So what happens this table? So now, first time what happens, the value is 0.91. When you want to compute with this by hand, it's going to take a little longer time. So this is easy, 0.9495. So we said I is varying from 1 to 10. So this is the only function we are using to look at calculus. Therefore, anybody can work on that for I equal to 1 to 10. So once you have 10 values are there, this is finally it comes to 3.49.99 when it comes to 3.5. Okay, so is it left limit says it is 3.5. What about right limit? So what is the change you are going to do? Right limit as the step value, you change it as well as the here 9. So this, if I take float is minus 1 by 10, this is 11 by 10 if I take, because we are going right side 1.1 onwards, we'll look at that way. So 1.09.8 up to 1 if you are coming. So 1, 1.01, 1.02. So this is the value you want. So accordingly, you define your step size and initial. So this is by practice. Once you understood what is we are doing in general, we write 1.01, 1.02. So how to convert in a programming way? Once you convert it, then the table gives this value. On computation, that's all I just computed. So 1.5 is 3. So obviously we got 3.5 is the answer. So this is fine. Why should I do directly? Because to understand, make the students understand it is, we know how to direct substitution. So x approaches to 1 does not mean that x takes the value of 1. So to define that, this is required. So we talk about much, irrespective of that, the students will just directly try to apply and verify it. So this is to tell them the difference between equal to and tends to or approaches to 1. So this is the way you're supposed to do, but the sophisticated way we'll do this way. So now you can practice this one. You just take those who are open it. So just do it. What is minus direction? Both direction, are we getting the same value? This is 2x squared plus x minus 1 divided by x plus 1. That is x tends to 1. The other one is x tends to minus 1. So x square minus 1 by x minus 1. So I did both here. One can try out and you can see this value, are we getting it? So direction is first is 2x square plus x minus 1. So I taken only x square minus 1. The second one I did this, you can practice it. So whenever you try, or take any book, just solve as many problems as you can. So familiarize with that code. So this is now x tends to minus 3. So when something is, when you say this way, x plus 1, x minus 3, it's going to be 0. The denominator is 0. Obviously, the answer is supposed to be infinity. So it throws the infinity here. So is it easy? I just want some interaction.
Yes, sir. This is going fine. And we are typing it side by side in Sage Math Cell also.
Okay,
so
very good. Yeah, very good. Yeah,
and
answer will come.
one more thing, sir. If it is possible to share the code in snippet, then
I'll do. See what?
Sir?
Okay. What I done is that's the thing I said. Coding snippet. I did not create it. I created in Jupyter Notebook. I can share it to you all. Is it okay?
Because it takes a little time to type also. If it is sharing, we can just copy and paste and see how the program runs and visualize the things also.
Okay. Now you want to share it, or how it
or
is?
we can, after the session, we can share the code, sir, so that we can work it out and see how the things are working.
Okay. What I'll do is when I go for programming part, I'll stop at the next problem because it's a nice problem. So I'll stop it. You can type it. Then we can go for it. Okay, that is a nice thing. Okay, next problem. I'll just, this is a famous problem. Probably might be come across. Probably might have forgotten also. In +2 level, we might have done this one. F of x equal to 2 star cos 1 by x does not have limiting value as x approaches to 0. So just to type the code in your Sage cell. I'll give some time. Then we can go for it. Others also, please open your laptop, go to Sage Math Cell, type this code. We'll go one, slowly we'll go. Hope you might have typed this code. Run it, evaluate it, and say the answer. I'm not evaluating it. Now I'll evaluate it. Probably might have typed it.
The answer 1.9299.
So the first value is 0.23, next value is 0.19, next is minus 0.29, minus 1.2. So after some time, it becomes 1.9. From this, we are unable to say it is converges, right? So it is not. So we have taken one side limit that is not converging. So therefore, we can say that it is not converging. So still we have a doubt. Should I do the right side, other side limit also? That's a question mark. So instead of this, so what happened normally we say it is not converging, we stop it. So how to tell the students, yes, it is not going to converge? Looks like, see, look at this. After certain times, it is between minus and plus. Looks like oscillating from this side and this. So this kind of problems only we can spend little more time, and we can tell the students. So this is a place plotting of a graph of this function helps. So when you want to plot this kind of graphs, it's going to take much time because cos 1 by x. So 2 times we have to multiply. So we have to find out the values. So this tools obviously helps us. So now I go here. See, this is the graph 1 by 10, 1 by 10. The plot f of x already we defined it. So I'm saying there's a big band is coming in between. So from this, still we are unable to say it is oscillates and other things. So can we zoom in so that we can see if it is bigger way? So how to do that? So instead of this 1 by 100, 1 by 100, if I take, so it looks like this, but still it is not going to give us better, but it is oscillates. That is very clear. So that's what I written. Zooming in on the graph has no meaning. So now the same way, you have to see the function x by mod x. Those who are in the soft computing, they know this is the Sinum function. So obviously we know the value. So this is the best example to talk about left limit and right limit not converges. So you can see that -1 and +1. So this you can do it easily and plot this one. So I'll copy this one, I'll paste over there so that in Sage cell, you can practice, you can do this problem. Okay. So this is our, okay, limit x by abs of x, comma, x equal to 0, direction equal to plus. Okay. So this is, I want to display this, say I'll put k equal to, some changes I'm doing it. so that you also will know L equal to limit x by ABS of x equal to 0 direction minus. So now I want both values. So instead of equal to sign, it is become. Yeah. So what I'm going to do is show, or I can put it as within bracket k comma l square bracket. It will print as a list. One comma minus one. So now you know how to pull out the values of this. So both values instead of being separately. So you know the first one is the left limit. Suppose if you're not doing it k comma l, if you give, then we can work on that with the RHS dot function. That function also we can use it. So now if you want to plot the graph, so you can plot the graph. So when you use on Sage Math, the math cell, it will, if I'm not putting this k bracket, this one, suppose I put k comma l. One comma minus one. Suppose if I want one by one, will it work? Now you look at this, only one is coming. Let me see whether it is appearing on the other side. No. So what is the meaning of that is, if it is, we are not putting this precisely, the output is, you should be play with this so that in front of in the class, you should not have this kind of doubt. Yeah, somebody raised a hand. Yes. Yeah, please, you can unmute your, somebody is asking some question. Thirmal sir. So Thirmal, who is coordinating, please.
Sir, yes, sir.
Unmute for one Ms. Satya or Mrs. Satya raised a hand. What's your doubt?
Sir, they can unmute themselves, sir.
Okay, once G Satya, that's what the name appeared,
Yes, sir.
raised a
G.
hand.
Satya.
Okay, if they are not having a doubt, okay, fine. So we given an opportunity to talk to them. If not, we'll talk a little later also. We have time. So now this is now you understood. So how to work with this and show the picture also, so that the students will convince. So this is a very important function in soft computing, and this as well as logistic function also very important. 1 upon 1 plus e power minus x or e power ax. So take that. That is also very important function. You can visualize. Okay, people are started unmuted for other purposes. Okay, right. Now, so trigonometry function, I said we did not do it. So now trigonometry function, when you do this way, the same approach would be, there is not much difference. So you should not have any problem. When if so, one small question, every one of us known to us, we know function and inverse function, how they are related. Please have that answer within you, analyze it, you have to recollect it. So once you recollect it, that is useful. When you are using this kind of tool, how do you know whatever we obtained is the inverse of the given function? Why do you require the inverse function? All those things are very essential in calculus. We'll talk about that part also. So sine 3x x equals to 0. So here I'm not taking this. So whether it is true or not, to verify that, you can just, the limit, whatever you take in, it's true or not, you can look at this. The graph is touching this one 3. So obviously the limit is 3. So you know this. So now this all to convince ourselves. So now what is the meaning of this function closer to the neighborhood, to help us to understand better, so whether it is correct. So now what we are going to do is the next is tan x by mod x. So as x approaches 0, what will happen? So sometimes when I defined as t, it will say variable is not defined. To avoid that, I defined as x. The default variable is x. If it is says error, then you can go for it with defining variable.
Sorry
So
for the
this-
interruption, sir. Can you scroll up, sir, for the sin 1 by x evaluation? 3
Yes.
by x.
Yes.
Yes, thank you, sir. Thank you, sir.
Okay. Same. So only thing is you just note down the function. What you have to do is between today and tomorrow, those who are interested or wanted to learn at least 5 problems from any book, take and just practice it. That is sufficient, because this all very simple, not complicated. So once we know this one, when we go for linear algebra using Sage Math, you feel much easier. Linear algebra, we have to do a lot of matrix operations. So obviously we required more coding. So therefore I started with this one. There is also not much coding because matrix can be put as a matrix. I can define it. I can work on that. That is also possible. Okay, so we have to play in order to get practice. Why do you require this kind of tool? Is Western world, students are given assignment based on various tools available. So since today we cannot, none of us can say, I am not having technology driven equipment. The kind of smartphones used by students is much costlier than a laptop. So obviously they will have it. So, and Tamil Nadu government also provides, that is also advantage. Okay, right. So when you look at this function, this is tan x by absolute x. Again, it is not limit exist. So obviously 1 and minus 1. So when you do this graph, how do you, previous one was much easier to convince the students. Here, if you look at this way, the graph is like this. We know that tan x itself, see all trigonometry functions, we supposed to remember the domain and range. So much useful to talk about this kind of problems. So we might have done it. Once again, we have to recollect it. So there is something called as, I'll put the link end of the session. Thirmal, please remind me. All calculus and summation, then some important functions, sequence and series, everything is given in one particular place, 10 page. If you have as a ready recorder, it is much easier. Students also can utilize that. So now this is the way we can do. So again, this is, there are 2 problems I given. You can do that. Note down the problem. Evaluate 1 by cos x as x approaches pi. Second problem is 3 power sin x as x approaches minus pi by 2. So 1 line code only. What you understood from this is only interaction with natural language way. Pi, we normally accustomed to write the symbol. When you use this tool, we have to remember pi stands for our 22 by 7 or minus 3.114. So that is the only part. So now for this, draw the graph. So once you draw the graph, you can see whether it is converges or not. So that's the way the graph looks like. So I've drawn the graph. So you can draw the graph also. So I'll keep here. You can do in Sage Cell. I also go to Sage Cells, 3 power sin x. Three power minus 4. I'll just put it this way. Anybody can say why it is error? Because this is exponentiation. Yes, yeah. So especially math is concerned, we are familiar with. The brace is supposed to be precise, then only we can work on that. Yes, the graph is coming. So now you can reduce the size, and you, because I'm projecting it, I put bigger size. Now you can see the graph. So this is the way you can go for a better way. So understanding this, as well as this is useful when you go for things by finding the slopes based on the direction. Also, we can talk about that. The four concepts what we might have studied in physics: time and speed, or time and velocity. They might have talked left side, right side. The horizontal tangents will have slope 0. That concepts and all, when you talk in the classroom, this tools is useful. So it delays the process, but once the students are familiar, then it is good for us. Okay, so this is two problems we addressed it. Right now, this is still yet to complete it. Error is there. Suppose this question is asked for limit extends to c for c equal to 0, pi by 6, pi by 4, pi by 3, pi by 2. So how to do this kind of problems also, because it's going to be every time you have to run it. Instead of that, we can use a for loop and we can go for it. There was an error in the morning. I did not correct it. So just I'm giving you what you are going to do is we are going to store these values in a list. Then you have to allow this index to vary. So that is a place I varies from. What is the value you're going to do that? That part you have to do, define it. So take this as a homework problem before tomorrow's class. I'll correct the code and I'll let you know. So sin x minus sin c by sin c as extends to c for c equal to 0, pi by 6, pi by 4, pi by 3, pi by 2. So 1, 2, 3, 4, 5 values. So this is the problem, right? So I'll put the problem separately. So this is the problem. So use as a practice problem using for loop. Define C, this values in a list, then use it. Hope you have taken 0, pi by 6, pi by 4, pi by 3, pi by 2. Okay, I'll go here. The same way, this is cos nx minus 1 by x squared for various values of x, various values of n as extends to 0. So here what I've done is just a simple line. Limit we have to find out as extends to 0. So we defined this is nothing but one line. Previous one I want to define using for loop in a list. I got an error. Then what I done is immediately I used the other way of doing the same problem. Don't use this method. Use define the various values in a list, then define it. So here what we have done is for table, then inside the table list. So therefore the square bracket for defining limit. So with the limit list we are defining the values. Therefore you are putting a or the usual parenthesis limit cos ix. So instead of nx, you can put nx here for n equal to 1 to 10. Also, you would have given it. So the same value you'll get. So one line we got all the values. So no need of going for that way also. That's what I said. Once you are familiar with the coding, n number of ways. There could be another ways also you can come up with. So we can find out this. So this is another thing very important. Limits involving infinity. So this is as extends to plus infinity minus infinity. What happens? There is no change in it. This is an important concept, limits involving infinity. Then, therefore, we talk about this part also. So this is the part, if you look at tracing of a curve, this is very important. So the behavior, end behavior of the curves and all, the limits involves with infinity or limits at infinity. So both are important. Limit tracing of the curves, the end behavior, when we want to talk about that, that is needed. So this is actually needed in the data science also. When you go for regression analysis, we supposed to know what is the least square methods and all those things, as well as when you go for the second order derivative equal to 0, equate point of inflection is also essential in data science. So it is not, calculus is not needed because of the coding we are talking about. Yes. So this and all we studied in the first year calculus during my time. So probably might have done it in the +2 level now. So could be. So you have to see a point of inflection, then stationary points. All those things are useful in data science also. So these tools are useful. That how to find that one when you go for first order derivative equal to 0, we'll get a turning point or stationary points. Find the second order derivative, then equate to 0. Some values will get, that is called as point of inflection. So then we talk about cusp, concave, convexity, all those things will come into picture. So calculus, it's an opportunity for me to recollect the calculus. So now as extends to infinity, there is no change at all. So only syntax is no change. When you know the syntax, only that x equal to a, instead of a, you're going to write it as x equal to infinity. So you'll get this value 3. This is another one is minus infinity minus 3. So to verify that, you can draw the graph and other things. So that's what I did here also. So if you would have put here x is minus 5, figure size are given, so you can see that. Okay, this is as I told you, 3 minus or 3 plus. If you do, only changes you're going to put the square root of 9 minus x square divided by x minus 3. So look at this. When you talk about square root of all those things, only square root is for this part. So minus infinity. So same way, another problem, limit cos x equal to infinity. So now this is okay. Cos x by x as x tends to infinity. Sin x by x. Okay, that is, we'll talk later. First, we'll talk about this part. So anything you can relate this one as x tends to 0, cos x by x, sorry, x tends to infinity, cos x by x. Any idea? Any discussion? Anybody can say something? Something we might have studied called as sandwich theorem or squeeze theorem. So take three functions, f of x less than or equal to g of x, which is less than or equal to h of x, as limit extends to a, f of x, the both extreme functions, f of x and g of x takes the value c, then the middle one also takes the value of same value c. Am I right? So that is what called a sandwich theorem. So how to do this part is, we know the cos x values lies between -1 and 1. So divide by mod x or x. So 1 by x minus 1 by x less than or equal to cos x by x less than or equal to 1 by x. Then you apply this condition, you'll get, because minus 1 by x as x tends to infinity, that is also going to be 0. This is also going to be 0. Hence it is. So that is what sandwich theorem, one of the applications we talk about. Some authors, some way they say pasting something extended, and they'll relate to, we have something called as pasting lemma in topology. So how these two are related, just give a thought. Probably I may give answer or I may not. So this is what I written here, minus 1 by mod x cos x by x, so h of x. So when you draw this graph, you can see this, the cos x by x lies in between these two. So therefore it is called a sandwich theorem. So when you say, instead of saying the statement way, you can take all the problems, around 6-7 problems are there. One is involves with e also, e power x minus 1 limit. Yes, that is also one more problem we come across normally. So that if you recollect those problems and put the pictorial way, okay, therefore it is works. So students won't forget it. So that is an advantage of this tool. Okay. Now this is as similar to the previous problem, but here we have to take two different values. Evaluate f of x equal to x power 2n minus 1 and x power 2 power m minus x power 2 m minus 1 as x tends to 1. So since I burned my earlier, I'm not going to use the list way. So I'm using the general way. Here, what is the advantage is when you say table, here I would have done it little more one. So now what I'm doing is limit x power k minus 1 divided by x power j minus 1 x equal to 1. So for this index, I have to define some values. So various values. So 1 to 8 and j is for this m, define it. I'm creating a table, that value is supposed to lie here. Suppose I want to have row header, after center I would have written header underscore row equal to some r1, r2, r3, r8. Same way column also I would have given column header, column header hyphen column equal to within the square bracket, within quotes, single quotes. If you write it, you will get the table nicely. So I centered it, so I got the value like this. So just you take this one, do it in the Sage Math. Cell, I remove this part. Let me verify it whether copied. Yes, center. Yes. Now I'll enlarge it. Are you getting the same values? Not same value. Are we getting obviously we'll get the same values so that you will have some codes with you. End of the day, you can practice it. So table. So this is I'll evaluate it. Yes. So if you are not put center, now what you can do is instead of center, this is where you can learn it. I'll put left. So obviously there's nothing big difference. All will be aligned towards left. So as per your need, you can play with this. So you can go for it. Okay. So as I said, derivative by first principle. So calculus always starts from that part. So I cannot use the capital delta and other things. If the code take work well, we know that syntax backslash, then capital D delta. If you type it, will get appear. It's not appear. Therefore, I put this. So using left and right limit exists. That's what I said. Some authors used to say point-wise definition of derivative. So this 1 by x use left limit and right limits. So the moment you say left limit and right limit, obviously you need some values for delta x we are going to take. So I'm defining here as more carefully. I defined as this ls I'm going to use for list. So what I've taken as 10 power minus 1, 10 power minus 2, 10 power minus 3, various values of delta I've taken it. So this, you remember this, I said this is needed when we go for calculus part. N of expression, comma digits equal to 4. We have seen the first example as n of pi. Pi is the expression, comma digits equal to 5 or 6 or 20, whatever you want, you will get the values. So that is we used it. Then here we are using this values. We want delta x, f of x plus delta x. Instead of delta x, I'm using the list value L of I. So L of I minus f of x by delta x. So L of I for I equal to, I've taken 8 values, I've taken only 6 values to see that. So it gives the value. So if we'll give like that, why should I do this way? Is there a direct way of doing this? So I can do that also. The variable limit f of x minus this one minus 1 by 4 x power square. So this is, you'll get directly, I can do limit f of x plus delta x minus f of x by delta x equal to 0. So this is the general definition. One can do that. So depending on your need, you can go for it. When you want to demonstrate with the table way, use table, otherwise delta x. So as I said, we can talk about continuity because continuity also defined the same way. What is the continuous at a point? Suppose you say the particular domain, f of x is continuous at a value a, limit extends to a, f of x equal to f of a. That is a definition. If this is true for the entire values in the domain, then we can say continuous everywhere. So when you talk about this way, so we need one is we can, the easiest way is draw the graph. There is no discontinuity, therefore hence it is continuous. We can say that that is all graphs cannot be drawn. Now with the tool, you can draw it. You can find out that also. So, but as per the definition, we want to talk about that. What are the definition we are seeing here? First is we have to verify limit extends to a, f of x equal to f of a. So first is we want to compare two expressions. So whether it is both values are same. So it is going to throw a Boolean value. We are going to verify true or false. If it is true, it is continuous. So first you're supposed to have the logic, then it is easy. So what I'm defining is the function I defined, x cube minus 1. New value we are going to take at continuous at everywhere, arbitrarily one value we want to take, variable a, limit f of x equal to a, f of a. So what is this assumption? Every polynomial is continuous known to us. Therefore, it's a polynomial, it is continuous. So entire real line, it is true. So when I said Boolean, this is a function first time I'm talking about. Boolean, limit f of x, x comma a. What is that? Limit extends to a, f of x. Is it equal to f of a? Double equal to sign. So comparing this, if it is true, therefore it is continuous. So this is one way of talking about this. End of the session, I'll give you one particular syntax place, a reading of 6 minutes reading. You know how to work with piecewise function using Python also. So that is one reference I added it. So that is useful to you, right? So find the point of discontinuity. Here, look at this, f of x equal to x square minus 1 by x minus 1. If x is not equal to 1, at x equal to 1, f of x equal to 2. Here the same function, at x equal to 1, f of x equal to 6. So we want to find the point of discontinuity. So the function, what I said is if then else, that is the way we are going to talk about that. Not equal to, so here explanatory sign equal to, if you put it, it is not equal. So we are defining this piecewise function. Excuse me. 1 minute. Switch on the power. All right. So now x is not equal to 1, return what is the value x square minus 1 by x minus 1, else return 2. So now whether it is continuous or not, discontinuity, we did not ask to find the point of discontinuity. Whether it is discontinuous or not, we are saying it the same value, Boolean limit f of x equal to 1, or whether it is true in the case of f of 1. Previously, we taken a general value. Here, a particular point, we are talking at this point, it is true, therefore it is. So now we are looking at this picture in the graph. So this is the line plot f of x equal to x minus 1. This f of x is what we taken as 2. So we'll see that figure size brown. So this is again to confirm it, whether the graph is continuously visible or not. So derivatives, again, this is all syntax is much easier. Now, differentiation, we are going to talk about that. Derivative, we have to find out. There are so many ways to define this. The first one is di f of f of x. So it's a single variable function. So obviously no need of defining with respect to what variable. The same thing can be written as f of x dot derivative. So that is also possible. Or diff f of x comma x. What is the difference between this is? So I'm differentiating explicitly. We are going to say that you are differentiating the function f of x with respect to x. Suppose if f is a function of x and y, so what you are going to do is you have to say with respect to which function. That is what I'm saying here, f of x comma x. So it is explicitly you have to say. Suppose I want to differentiate this as, here I written only f of x supposed to be x comma y. So that is a syntax error. I made it. So you have to correct it. Now, nth order derivative, you want to go for it. First is with respect to which variable. Then what is the n? N equal to 3 or fifth derivative, whatever you want. So this is a pointwise definition is known to us. Limit h tends to 0. F of h plus a minus f of a by h. So this is what going to give us pointwise definition. So we can say find the derivative of f of x equal to x power 4 by 3 at x equal to 1 by pointwise definition. So what is the meaning of that? As you have to choose various values of h. So we can compute the same way like last time. So what I'm doing is, you remember that we express in terms of h, then we apply h tends to 0, only the term independent of h will get. That's what we do in the classroom. The same approach, if we deploy it, what will happen? So a is some value, because at x equal to 1, so the a is 1 I defined as. So a plus 1. So look at this, f of a plus h minus f of a divided by h dot simplify full in the sense that it gives the expansion of this entire value, that is h cube by 3, 4 by 3 times h square plus 2x plus 3. Now you apply limit. For this, if you apply the limit h tends to 0, you will get 4 by 3. So that is what we are going to talk about. So limit h tends to 0. So both ways, either you can do that pointwise definition table way, or what we do normally in the classroom, the same way also you can do that. Now, what we are doing is we are going to define this. This is what we know, that the derivative is nothing but slope to the given curve at a given point. So that is what we are going to verify, and how we are going to do is with the graph only. So what we are doing is, this is known to you. So f of x is as it is, we are defined how to plot is also known to you. Now we are putting the differentiation of f of x in a variable. So that variable I'm calling differentiation of the function x. Now both plots we are going to do it, that I'm going to call it as, that is differentiation. This plot we are calling this fn1. Then differentiation of this f of x we are calling as differentiation function 1. So this is known to you. What is that? F dash of a into x minus a plus f of a is the equation of the tangent line. So use that property, what we known to that. Then both draw in the same axis. So you'll get, so at x equal to 1, it passes through that as a tangent. So this can be explained this, whatever the way you want, you can talk about that. So now, this is what I said. Equation of the tangent line at f of x at x equal to is given by f dash of a into x minus a plus f of a. So derivative, now sometimes what we do is, this is family of functions. This we talk in the +2 level. If you remember that, instead of given a value, we'll compute in terms of a variable. So we call it as family of functions. So have various values of that particular variable. So that is what we call it as derivative of a function. So derivative of cos x square, evaluate at x equal to square root pi by 4. So what we are doing is, we are exploiting, instead of finding that way, what I can do is I can store this as differentiation of f of x is g of x. Then I can say g of square root of pi by 4. It gives the same value only. So instead of that, we are exploiting other syntax also. Differentiation of f of x dot substitute x equal to square root of pi by 4. So which is going to give us some answers. So square root of 2 to square root of 5. So this is, one can talk about that. Now f of x cos x by x if x not equal to 0 and 0 if x equal to 0. Again, it's a piecewise function. So now when you want to do that, look at the domain of these functions. Then based on that, one can use the piecewise command. So both domains are separate. Then we can use the piecewise function and evaluate it. So this problem, how to define, I'll say. So f1 of x is cos x by x, f2 of x is 0. This what given. We have changed as, instead of f of x piecewise function, as 2 function, because both are different domains. So piecewise, so at 0, 0, because at x equal to 0, only 1 point, therefore I'm defining as 0, as f2, that value is 0. Then except 0, at all other places cos x is defined. So minus infinity to 0, f1, 0 to infinity, f1, union of this. So this 2 in the interval, you are defining it. Only syntax you're supposed to know, piecewise. Then if you put f derivative, you will get this one, or you can put differential of f directly also, you can do that also, right? So find the equation of the tangent line to the graph. 2 problem is given, f of x equal to square root of 2x plus 2 at x equal to 2. The other one is f of x equal to x square plus 1 passing through the point 2, minus 3. So draw the graph of the tangent line to the given graph of the function. So any method you want, you can do it. So that's what we did. First is, okay, this is variable x not defined. So I can, without that also I can do, just to convenience I defined it. F of x equal to square root of 2x plus 2. So this directly equation of the tangent line is written f of a plus f dash of a. That is what we are writing. Substitute x equal to this. All stands for f dash of 2 times x minus 2. So then we throw the line outside. So 1 by star x square root of 6 into x minus 2 plus square root of 6. If you draw the line, you will get this graph. So now this is the way you can play around this. So now the same thing, what we are doing is, instead of defining that way, finding the slope, from that substitute x equal to a, solve for this. So we'll get here, when you say this one, this solve for this minus I, capital I in Sage Math represents complex number. So these 2 roots are in the complex numbers, so we cannot do that because we are in the real value system. So obviously this is the root here. Now find the higher order derivative. So suppose I want higher order derivative. If it is 1 derivative, fine. Suppose third order derivative, differentiation of diff f of x, 3, it will give the third order derivative. We normally used to ask, find the first 3 derivatives, find the first 5 derivatives. So when the question is like that, it is easy. Differentiation of cos x, x with respect to x for I. The I is taking values from 1 to 5. So that is, we are going to get cos x derivative is minus sin x. So minus sin x derivative is minus cos x derivative sin x, cos x minus sin x. So this produces as a list. Sorry, from coming from my phone. Okay, can you do this problem? Find the first 5 derivatives of f of x equal to x times sin x. So now, so far we are seen as a single function. There's a product rule we needed. So one can use product rule, quotient rule, whatever you want, you can use it. But here the function is same. So I'm not changing anything else. Even though it's a product x star sin x, Did I do anything? Well, look at the syntax. Differentiation of f of x comma x. Without understanding the product rule, one can solve it. So the answer is x star cos x sin x. So I said first 5 derivatives. Now what I'm doing, this is the first derivative. Now second derivative I'm doing it. So one is I can use for loop and exploit in one line, I can compute it, or usual way, find out second derivative, third derivative, fourth derivative like this. So, but I have to 3 derivatives, then I use the for loop. It's boring. So now, because nth derivative is familiar, so obviously we can do directly for I equal to 1 to 5. So all those values are in a list we can call. Chain rule and implicit differentiation is here also. We are not going to have much difference, but you should know what and all we did. So find all horizontal tangents of f of x equal to square root of 2x power 4 minus 2x plus 1 divided by 2x power 4 plus x plus 1. So only thing is horizontal tangent. Here what we are to do is derivative, the slope supposed to be 0. That part what we are going to use is we are going to use the syntax of solve. So that is what important. So here what I've done is differentiation of f of x as well as simplify fully. So it will simplify so that it's easy for us to work. So that is the only thing. So first we found, then what you have to do? You have to equate to 0 and solve for x. So for horizontal tangent, slope must be 0. Hence we have solve for solve f dash of x equal to 0 for x. Solve differentiation of f of x equal to 0 with respect to x. So it will give, so this is equation is going to give us x1, x2, x3, x4, 4 values. You look at this, the first value has I imaginary, the second value is not real value, third value is imaginary, fourth value is real value. So when you solve this value, this second one, 6 power 3 by 4 divided by minus 6. So obviously we'll get some 1 minus. So this value is going to become as 0.639. Use calculator or one do it some way. Fourth root is also minus 0.63. So now we have to verify the same thing with respect to plot, whether it works or not. You can see that. So whenever you are doing it, you can verify with the graph. So in order to convince ourselves. So you know this is lemniscate looks like a infinity in this way. So the equation is obviously known to us a times x square plus x square whole square equal to 15 x square minus y square plus or minus. If you put that generally. So in order to do that, find the differentiation, you need implicit differentiation. So or what you can do is convert this y as a function of x, then usual differentiation. So both ways are possible. Whichever way you like, you can do it and you can compare it. So this is I didn't want. Now, so derivative of an inverse function. So find the inverse function 2x square minus 2x plus 1 on minus infinity comma infinity. So it's obviously 2x square. The quadratic equation when it comes into picture, the function is not 1, 1. So hence inverse cannot exist. So what you have to do? So we have to restrict the domain. That's how we studied. Whenever we looked at the inverse function, if it is not 1, 1, we cannot find an inverse. Obviously, we have to go for restrict the domain to find out. Then we can go for it. So to express that, first is easy way is draw this one. The meaning of this is 2 equal to this side also 1 point, this side also 1 point. Therefore, it is not 1, 1. Hence, it is. So to convince that level, so it is easy, the pictorial representation. So once you have this, so now what I'm going to do is so restrict the domain. That domain, when you draw, the function happens to be 1, 1. So we can find inverse. So now to find inverse, what you're going to do is normally what we do, we put y equal to f of x, then solve for y. So the same process here also we are going to do that. So variable x comma y, even though it's a single variable function, we are defining y. Solution equal to solve f of y equal to x equal to x. We are solving for y. Am I right? Y equal to f of x, and we solve for that same thing. Doing it. Solution is we are going to get y equal to minus 1 by 2, 2x minus 1. So this is the solution, we'll get it. So now when you look at this, I want only one value because we want positive side. So it is minus is there, plus is there because we are taken this side. So positive is required. So therefore I want the second component of this. So how to extract the second component? So this I stored in the variable solution. This is the representation is the index is 0. This is 1. Therefore, g of x I'm defining as a function g of x equal to solution 1 1 dot that index 1 dot RHS. Only it will extract RHS of the solution value. So that is going to give us 1 by 2. So now you can see that how to extract. Why do you require this kind of thing? Suppose you are finding an eigenvalues, you want to find out particular eigenvalue. So you can pull out using this kind of RHS function. So now this is what I asked you to remind it. Suppose you found, just now we find the inverse of this. How do you know it is whatever we obtain is the correct result? One way is you can see that f inverse of g of or f inverse of f of x equal to x. So algebraically one can do that way. The other way pictorially, what is that? Any function at the inverse always it's a symmetry with respect to the line y equal to x. So reflexive with respect to y equal to x. So we can use that property to verify that. Therefore, I drawn this graph whether the function f of x and g of x is the inverse of f of x. Some range I given, figure size y minimum and y max. You can see that it's a symmetry with respect to y equal to x. If you draw it, you can see that it is one and the same. So the same way, if the function has inverse, if exists, compute f inverse, the derivative of f inverse at x equal to 2. So very easy. So one line I want to do it. So therefore, what I done is I defined number of variables more. F is a given function, g is the inverse, x comma y equal to solution. So now this is finding inverse. Solution is for inverse. I'm doing it. Then solution, if you put it here from here, which is the real part to pull out? So y minus 1 by 2 square root. Okay, this has I. So I is there, therefore it is not. So this is also I. Only one is out of 3. Only one is the real part. So that is the second component. That is the last one. So therefore we are pulling out the last one. So then you pull out g of x. So this n differential of substitute x equal to 2 digits 2. So this is we are defined as g of x. So we want f inverse of the derivative of inverse function at x equal to 2. So that is we are pulling out differentiation of this substitute x equal to digits 3. So we get 0.027. So I have this one. I'll stop after exponential and logarithmic function. So you should know this is no need of talking about this. Just now we talked about inverse functions. Obviously, exponential and logarithmic functions are inverse to each other. About the line y equal to x, if you see that reflection. So obviously you will get there's a standard things. Now this is again you can take it as 2 power x. So all involves with e power x and log x. So what will happen this? So in the logarithmic x, okay, now you may ask, suppose the base is different, how to do that part? So we have a standard answer, convert into the base e, then do it. That normally many of us commit mistakes. Even I was doing this mistake earlier, but before teaching, somehow we are tuned to that differentiation of logarithmic x is 1 by x. The base is only e. What is the base with respect to 10? We won't remember that part. First is conversion, we might have forgotten. Please, whenever you teach calculus, please tell the students this is only with respect to e. Otherwise, you have to convert the base, then you have to do it. Those who have done numerical analysis that time, they will remember this because there is a famous problem 10 into log x minus 1.1 equal to 0. Most of the books talks about the problem. What is the specialty about that problem? I'm not sure about that. Most of the textbook that problem is available. So therefore, you can look at that. That is a point. So log x, how to write here is log of bracket x. You have to write it, then only we'll get here. So this is same. We are not done anything else. So just differentiation of the given function, you write it, you can do that. So this is a normal problem. What we do is find the point on the graph f of x equal to x square times e power 3x plus 5 plus 3x, where tangent lines are parallel to the line y equal to 3x minus 1. So now we know we have to find out the slope. After that, find the slope, then both are equal. So we can find out that way. So here, easily what we can do is f of x is there. So we have to solve, equate to this tangent line, so parallel to, so that equal to 3. So slope of the line is 3. So we have to equate the difference in the slope of the point at that point x equal to 3. We have to calculate it. So directly we are able to write solution. This is the line solution. Solve differentiation of f of x equal to 3. So comma x with respect to x we are finding out. So you can see that x equal to minus 2 by 3, x equal to 0. So two solutions are there. Both solutions are stored in x1 and x2. This is 0 index and 0 index. So now you are computing f of x1, f of x2. That values are, one is 0. That is, other one is 4 by 9 e power 3. Now you have to represent in a graph. So that is the tangent line equation is known to us f of a plus f dash of a into x minus a. So that is what we are doing here. So then put all the graphs over here. You can see that that line also written. K1 and K2 are we defined. This is f of x. So g1, gx. So you can see, you can prove that you have done what is expected. So this is the place. I'll stop here. So I'll say what are the things you have to refer as. This book has a lot of problems. This book is available on chapter wise. This book is useful for learning any calculus with Mathematica, Maple, or anything. So calculus and modeling and application, second edition, David A. Smith and Lawrence C. Murray. This is a nice book. Then our book with respect to applications. Okay. Then this is the where you can learn calculus. Whatever I've done it mostly from here and this book only. Any book on calculus for problem perspective. So this gives you only with respect to piecewise how to do with respect to Python as well as Sage Math. So this talks about slightly different way. I used if then else part. They are using the syntax of piecewise. Then this WordPress.com is the blogging site. So this Priyanka written a very beautiful article how to use piecewise function in Sage Math. Also, she's talking about discontinuity with pictorial way. So this is just given you an outline or small introduction to this. And when will you become master or some kind of expert in it, you attach with your course, then you start teaching it, then it is useful. Otherwise, we know minimal, the environment is known to us, we may not learn. So number of places I change the syntax because of that only. I don't want to go with only one syntax. So variety of syntax are available, use it. So you also can put a small blog or anything, some calculus course material would be nice. So all of us can utilize that. Okay, I'm open for questions. So now I have another 16 minutes, so we can discuss something before I go there. Now, what is left in calculus part is one is application. So application, and obviously we talk about the global minima and local minima. Then first derivative test, second derivative test, when you have to use it, how pictorially one can verify. That way I can go for it. If I go that way, applications of derivative is going to take more time. So one or two problems I'll do it. Then I have to go for integration. So that would be sufficient for tomorrow's things. Today I'll send this Python Jupyter notebook to organizers. They will in turn give to you. I'm open for questions.
Participants, if you have any questions, please unmute yourself and you can go for the questions. Any questions from participant side? Sir,
Yes.
One thing is, when we do the derivative part,
Right.
How do we extend this to partial derivatives and visualize the partial derivatives in
Okay.
Sage?
Right. When the moment you go for partial derivatives, obviously I have to go for 3D plot is much better. So I work very minimal with partial derivatives because I introduced this one for the calculus part and pre-calculus part.
Okay, sir. Because when we, yeah,
possible. I can give you that tomorrow. One or two things I'll put on the partial derivatives and visualization of that.
Because mainly when we extend our derivative concept to the higher dimension, this tangent line becomes the tangent plane there.
Correct.
So many of the time we tend to miss the tangent plane, how it intersects the surface and what is the meaning of the partial derivatives. That if that visualization is there, people may understand it better way actually.
No, that is there. That's what I said. We have to go with 3D plot. Then it is easy. I'll put you certain some examples based on that. Anyway, tomorrow also we have session, so that's the reason I asked 2 days time.
Sure, sir. Thank you, sir. And this is really helpful for the participants from big starting point of view, like how to start using certain softwares for the teaching purpose of calculus, actually.
Yeah.
So any other question from participants? Please unmute and you can ask.
Good afternoon, sir.
Yes.
Am I audible, sir?
Very well.
Sir, it's very nice seminar, sir. Really, it's very useful for us. Being a research scholar, I could able to get some of the code related to calculus and real, sir. So, what's my question is whether it supports some higher order matrix for a matrix multiplication. Whether it supports the higher order matrix for to say in batch mode model like that. Whether we could apply that higher order matrix, sir.
Obviously, it is possible. I said the Sage Math is built on IPython architecture and Macaulay software. Macaulay software, we can do all kinds of matrix manipulation. So when I opened it, Macaulay 2, Sage Math Cell, I've opened it, you have seen it, GW, GR, and all those things, all are symbolic computations of matrix, mathematical operations only. If you are very keen on a particular thing, Octave also you can use it. Matrix, any kind of matrix, because Octave is an open source equivalent to MATLAB, so you can find out it. But with Macaulay, I can do that part, any kind of. So what is your order? Are you talking about 100 matrix multiplication?
Yes, sir.
Okay.
Yes, sir. Some hundreds.
Okay, some hundreds. So then first one is your computing resource is not sufficient. With laptop, we cannot do that way, or you have to go for the partitioning of the matrices, then you have to go for it.
Okay, sir. Okay, sir. Okay, sir.
Based
Thank
on
you, sir.
your the structure of elements in your matrices, you have to create an idea. Or the general matrix, if it is a sparse matrices, then we have a different method. Suppose if it is a centrosymmetric matrices, then for example, if you take a 3x3 centrosymmetric matrix, the distinct number of distinct elements and how it is placed, if you look at that, based on that, we can go for it also. The most probably what we do is, once you go for higher order matrix, the easiest way is make diagonalization, right? Once you diagonalize it, all the values are going to sit in the diagonal only. You're going to multiply 100 times or whatever it is the diagonal elements. That's
Yes,
the best
sir.
way than looking at software and other things. So how to diagonalize a given matrix? Yes, possible. So then you can go for it any order multiplication is concerned. Suppose some other operations. So based on your applications, we can talk separately that part.
Okay, sir. Thank you so much, sir. Thanks for the organizers also. Thank you, sir.
Any other question from participants? Please unmute yourself and you can talk. Sir, one more question from my side is that when we go for this maxima minima concept, is there a inbuilt syntax in Sage for identifying them, or do we need to write a program?
There are syntax are available. See, there are codes are available. Immediately we can pull it out, maxima minima. See, the problem is when you do this way, we lose the concept. How many of us are really understood the least square method, irrespective of those who've done statistics? Fine. They know we call curve fitting, and from there we say minimize this, therefore we go with that way. Am I right? For identifying the coefficients. That is what least square, and people still, this is nothing but no way it is different from the maxima minima models. Am I right? Because there also we are equate to find the partial here derivatives and equate to 0, find the stationary point, substitute this value, second order test. Same process we are doing it. The link is missing between one subject to other subject. Therefore, we are unable to find out it. Otherwise, yes, there are codes. Directly we can do it.
Okay, sir. Any other questions? Participants, please. If you have any questions, you can.
Sir, one question, sir. I just want to know whether this supports for solving the simultaneous equation. Because for solving the simultaneous equation, usually we go for the numerical methods. Will this support that, sir?
No. See, simultaneous equation, I put directly one of the examples I quoted it. There are two kinds of simultaneous equations can be solved. You are talking about system of simultaneous equation. You want to go with numerical methods. When will you go with numerical method? That's the fundamental question, right? Suppose you want to exploit some of the existing methods, then yes, you are going through matrix method or iterative method. The moment you go for iterative method, any method you go for it, it's a programming way, you can do it. So it supports.
Okay, sir. Thank you, sir.
So it's built on Python. So Python is useful for matrix operation. All those things are possible here also.
Okay.
Sir,
Yes,
sir. So for each and every problem, we have to write a programming code, right, sir? Is there any basic programming skill need for to write a code?
No. I used only one code. One is table of list for I equal to 1 to what is the range you want. Beyond that, not required to teach calculus at the undergraduate level. Suppose if you are doing beyond that, then you need minimal, some kind of skills is required. That is also not much.
Like C plus and programming C plus like that, sir?
No need. So if you know Python, you can run Python here.
Okay. Okay, sir.
Not much, very minimal.
Okay.
1 line or 2 line based on the problem.
Okay, sir. Okay, sir. Thank you, sir. Thank you.
And sir, from a teacher point of view,
yeah.
Is there a command like input command where we can just give the inputs of each and every problem and get the output? Because every time I have to change the code with the corresponding problem, that may be like tough for me. Something right. Like input command is there so that I can run for multiple problems with the various inputs and get the result, right?
No, that's so the thing I used Jupyter Notebook. You can use that is called as Jupyter Notebook merging with Sage is called as Sage Math Note.
Okay.
So that is a place. Now, what is the thing is when you want to put the problems, then you'll know minimal of markdown skills are required. Like it won't come inside the square box. It will come as a big font and block letters in the outside of the box. So that is very simple. Single hash, it's a big, bigger font. Double hash, smaller size. Triple hash, smaller size, like that. Double star, if you put before and end of this, that time it will become as a bold letters. Then our usual LaTeX codes works inside the Jupyter Notebook. So the markdown language. So as we write the mathematical equation front and beginning, we'll put a single dollar and we'll go for it, right? The same thing works over here also.
Okay, sir. Any other question from participants? Okay. As there are no questions, I think we will have more interaction as well as information in tomorrow's session to go about this Sage for calculus. And I would like to thank Venkatesh sir for introducing this Sage math for teaching calculus. It's not only for just getting the answers, visualizing, and also try to understand the math behind it. It will really help us to understand the problems, as well as it creates the curiosity among the students to see the function and how that works and all. Just doing the steps and getting the answers, rather than doing that, if we start doing like some kind of visualization, that will create some interest in students. And for that, I would like to thank you, sir, for giving us this introduction part of Sage Math. And we would like to see more in tomorrow's session. Thanks a lot, sir.
Thank you very much. Yeah, thank you.
And the participants, the feedback form, we will have it tomorrow, and we will wind up the session. We will wind up today now, and tomorrow at 10 o'clock we will join back, and we will know more about the Sage Math for calculus. Thank you all for joining us today, and we all see you tomorrow.